Hi, boys and girls. Welcome back to Mr. Siedebach's geometry class. Here's what we were working on today. So go ahead and open up your ebook to this lesson. Feel free to pause the video if you need some time to get there. And don't forget to take out your pencil and paper and write down today's lesson target. Feel free to pause the video if you need a second to get those out and to copy it down. What, you think it's weird to wear a bike helmet with a shirt and tie? Whatever. Let's get started. Today we begin the third section of Chapter 7 with Lesson 7.3.1. What makes a quadrilateral special? Studying quadrilaterals on a coordinate grid. You'll see that I'm in the ebook today, and I'll let you know why in just a moment. But first, go ahead and read the lesson introduction, and then problem 7-115. For that problem, they ask you to write a list. You can write a list, or you can simply just take out your notes or your toolkit and start thinking about what they're asking you for. Okay, go ahead and do so, hit pause, and then play when you're ready. Hopefully, when thinking about the properties of those different quadrilaterals, you referenced our toolkit from Chapter 7, where we wrote down all of the definitions and special properties of all of those quadrilaterals we've been studying. Now on to problem 7-116. I'll go ahead and read it. Review some of the algebra tools you already have. Consider two line segments, AB and segment CD, given those following 4 points. A, draw these two segments on a coordinate grid. Find the length of each segment. So for doing this, you can do this on graph paper, which will be great, but you can also use this feature where you see the calculators link down below and where it says Desmos graphing. If you click Desmos graphing, it opens up a new window with a Desmos graphing calculator. This is really beneficial for making calculations and graphing points and lines at the same time. If you have a handheld device, you can also download the Desmos app, which is what I'm going to use in this video. Let's continue. So in 7-116a, they ask us to draw the two segments and then find the length of each segment. I'm going to use Desmos, as I mentioned previously. Okay, so in order to draw these segments, we're going to insert a table. So hit the plus sign and then insert a table. The first point will be 0, and the second point, 8. Below, we have 9, 2. And you can see it plots for us the 2 points. Now, I can connect these points by making a segment, by selecting line. Okay, so there's segment AB. Now let's make a table for segment CD. So I have 1, 3, and 9, 15. I hold down that purple circle, I select lines, and there is my segment. As you can see, I took a screenshot of the Desmos window and I copied it over to Notability where I can write on it. That's going to help us as we complete letter A where they say find the length of each segment. So here I have segment AB and segment CD. Now, find the length of each segment. You can use the distance formula if you like that, or you can use the Pythagorean theorem, which the distance formula actually comes from the Pythagorean theorem. For this video, I'm going to use the Pythagorean theorem because we can always make a right triangle with 2 points on a graph. All right, and we're trying to find the hypotenuse of this right triangle, which would be the length of segment AB. And so we can see here that the length of the vertical leg is 1, 2, 3, 4, 5, 6. And the horizontal leg is 5, 6, 7, 8, 9. And so I can say 6 squared plus 9 squared equals c squared, and then solve that. 36 plus 81 equals c squared. That you add those up, and you have 117 equals c squared. And then to calculate, which you can also use Desmos to calculate this, we get c is approximately 10.8 units. Go ahead and do the same thing for CD. You can use the Pythagorean theorem, or you can use the distance formula. Right, there's the right triangle for CD. And here we have a height of 12 and a base of 8. And so 8 squared plus 12 squared equals c squared. And so 64 plus 144 equals c squared. 208 equals c squared. Take the square root of both sides, and we get c is approximately 14.4 units. So this is 14.4, and AB is approximately 10.8. On to letter B. Find the equations of lines AB and CD. Write both equations in y equals mx plus b form. I'd like you at this point to write and do your best to write the equations for each of those two lines. And remember, to do so, you simply need to find m, which is the slope, and b, which is the y-intercept. Okay, so hit pause and give it your best shot. So in doing this, we look at these two lines and we can see AB is quite easy for us to do because we can quickly see both the slope and the y-intercept. The slope, m, equals the rise, 6. Now, because it's going down from left to right, that's going to be a negative 6 because this is heading downward. And the run, 9. So rise over run would be negative 6 over 9, which simplifies to negative 2/3. And then B, our y-intercept, can easily be found here because we already have that point, 0, 8, 8 being our y-intercept. So B equals 8. And so we can now write our equation, y equals mx plus b, m being negative 2/3, and b is 8. Okay, now CD gives us m because we already have that slope triangle. So the rise is 12 and the run is 8, both positive. So m equals 12 over 8, and that simplifies to 3 over 2. What about b, the y-intercept? As we can see, the segment comes short of crossing the y-axis. So we have to extend that line in order to identify what that y-intercept is. You can also use some substitution to do this without extending the line if you'd like to do so. A third way is by using Desmos, which provides a really nice way for us to find y-intercepts and to create lines from segments. And so here we have segment CD, but it's just a segment. It's not a line. It has two defined endpoints. So what we can do, and if you notice that CD has variables x sub 2 and y sub 2. So we're going to write y equals mx plus b, but instead of y and x, we're going to put y2. Y equals mx2 plus b. Now you're probably looking and saying, well, that didn't work. The line disappeared and the values in the table are gone. You're right. It doesn't work if we use an equal sign. But in order to create a line from data in a table, if you replace the equal sign with a tilde, then it creates a line segment through those points. And as you see here, it also provides us the exact y-intercept. So that's pretty cool. So going here, we can see, okay, b equals 1.5, which, if we're going to write the slope as a fraction, let's go ahead and write this as a fraction, is 3 over 2. So our equation, y equals mx plus b, m is 3 over 2, and b is 3 over 2. And there are your equations for AB and CD. On to letter C. Is AB parallel to CD? Is AB perpendicular to CD? Justify your answer. So before you get started on this, remember, or let me ask you, what does it take for lines to be parallel, and what does it take for lines to be perpendicular? I'll give you a hint. You can tell by looking at their slopes. Hit pause and see if you can find what we need to look for to determine if they're parallel or perpendicular. Hopefully you found if two lines are parallel, they have the same slope. If two lines are perpendicular, on the other hand, they have opposite, which means plus to minus or minus to plus, reciprocal, which means the numerator and the denominator flip, opposite reciprocal slopes. Okay, so let's look at our two slopes for this problem. We have negative 2/3 and 3 over 2. Are those the same slope? No, they obviously are not, which means they are not parallel. Are they opposite reciprocal slopes? Yes, they are. Negative 2/3 and positive 3 over 2 are opposite reciprocal slopes, so they are perpendicular. So we will say perpendicular because negative 2/3 and 3 over 2 are opposite reciprocals. Excellent. Lastly, on to letter D. Use algebra to find the coordinates of the point where A, B, and CD intersect. In order to use algebra, we're trying to find this point right here. We need to solve the system of equations, the system just being more than one of something. And so we are going to copy this equation and this equation. and we're going to solve the system. So one of the simplest ways to solve a system of equations is if one of them is set to equal a variable, which both of these are, you can use substitution, or since both of them are, we can call it the equal values method, where both y's equal each other and they also equal these two values. So we just set those two equal to each other. So we have negative 2/3 x plus 8 equals 3/2 x plus 3/2. All right, and we go ahead and we solve for x. So I'm going to add 2/3 x. Why don't you go ahead and pause the video and try and solve this yourself, and then come back and hit play to see if what you got is actually correct. And now we have the solution to the system of equations 3, 6, which means that is where these 2 points intersect. Now you could have just looked at the graph and seen that they intersect at 3, 6, but by solving the system, that's how you prove it algebraically.